CFA Level 1 May windowers, you have now 11 days left until the May window creaks open. And this is the fourth video. I'm doing one every day in the last 14 days until the exam to go over a fundamental concept from the CFA curriculum that typically people don't like. And today it is put call parity. I think people don't like it because there's such a proliferation of formula sheets out there and mnemonics that people just stare at the letters, learn a formula, and don't understand what's going on and how it's applied. And that is meant to be the point of the Level 1 derivatives learning outcomes. So that is what we are going to do. Here is the formula in all of its glory, all 5 elements of it. On the left, we have S0. That represents a long stock, going long on the stock, buying the stock at a price S0. That is coupled with P0, a long put. So you are buying a put option on that stock. On the right, C0 is the price of a call option today. That is a long call. And you couple that with PVX. That is an investment. An investment in a risk-free instrument that will, when it matures, pay X. If it's a risk-free instrument and it pays X at maturity, if I discount it at the risk-free rate, by definition, it would be priced today at PVX. Now, those of you who are mathematically inclined will have spotted that adds up to 4 elements. The fifth is the key to the whole thing, the equal sign. That is fundamental. The clue is in the name, put call, parity. The whole point here is that it can be shown that the long stock and the long put together, known as a protective put, but that's not the point of this video. Put them together, it can be shown that their payoff will always be equal to the payoff on the call and PVX, known as a fiduciary call. Again, not something we care about particularly. This is what we care about. The payoff on the left-hand side is always equal to the payoff on the right. They're not always equal to the same number, but they're always equal to each other. That means in substance, economically, effectively, both sides represent the same asset. They're going to pay off the same. And if that's the case, they absolutely must cost the same. If they don't, you could make arbitrage gains. Let's demonstrate it. We have here an example. For IBM, 6-month 270 strike. Risk-free is 4. We'll use that shortly. We're going to compare the protected put and the fiduciary call. And we're going to look at the payoffs in 2 scenarios. First of all, we'll look at what happens if IBM stock at expiry is priced at 250. Note, that means at expiry, the underlying is worth less than the strike. The strike is 270. What do we get out of our protective put, S and P? Well, the underlying at expiry is worth the underlying. We're just told there it's worth 250. What about the payoff on the put? Well, the underlying is worth less than X. The put is the right to sell. The right to sell has an intrinsic value at expiry when the underlying is worth less than the strike. You can sell it for 270 when it's only worth 250. Your payoff would be 20. The protective put is paying off 270. What about the fiduciary call? The call option. That's the right to buy at 270. It's only worth 250. That is out of the money. That will be allowed to lapse and gives you nothing. PVX by definition grows to X at maturity. The strike of 270, the fiduciary call pays off 270. When the underlying is worth less than the strike, they both pay off the same. What they pay off is the strike. But what if the underlying is above X? What then? Well, the protected put. You have the underlying, you have the 300. But the put is out of the money. Now you have the right to sell at 270 when it's worth 300. That expires worthless. The fiduciary call. The call is now in the money. You can sell at the strike, which is above the underlying. Sell at 300. It's only worth 270. The payoff is 30. PVX, once again, by definition, has grown to 270. Plus 30 is 300. 300 plus nothing is 300. Yet again, they pay off the same as each other. What they pay off when S is greater than X is S. In both situations, it does not matter where the price goes. These two strategies will pay the same. If they pay the same, they must cost the same. Now we have an extremely powerful piece of knowledge. The cost of this side is equal to the cost of this side. How can we use that? Well, we can derive the cost of one of these securities from the others. Which you might be saying is pointless, Richie, because I can see them all on my screen. Yep. But in the exam, they might make you jump through these hoops, so there's that. And in the real world, if these don't line up, and they're far enough away from each other to offset transaction costs and taxes, then maybe you can make a nice little arb out of it. Let's demonstrate how. Let's imagine the examiner has asked you to isolate the put. How do I do that? Well, what I don't do is learn 5 different versions of the put-call parity formula. Just do a bit of algebra. You want to isolate P, just get rid of S. That means getting rid of S from here and getting rid of S over here. That leaves me with just the put. And on the right-hand side, the call, the PVX, minus S0. I have isolated on the left the long put. This is a long put because it's got a positive. It's a silent positive sign there. You could see it. On the right, because I've done the same thing to both sides, this equal sign still holds. The right-hand side is still equivalent to the left. This is also going to pay off what the long put pays off. We say it's a synthetic long put. What's it made up of? A long call. That's a silent positive. We don't draw it out when it's just there, do we? But it's a positive sign. That is a long call. So the synthetic long put is a long call. Plus PVX. We invest risk-free in the bond. But be careful. Minus S0. That means, because it's negative, short on the stock. If you short the stock, invest in the bond, and go long on a call, you will get the same payoff as a long put. It is a synthetic long put. These three together replicate the long put. Now, we've got a couple of numbers in here. Let's just play around and see if we can calculate one of these. Let's say today, right here, right now, 6 months. We're going to assume, just to keep the calculation simple, it's exactly 6 months before expiry. Let's say today, with 6 months left, the call with a strike of 270 is trading at 795. The stock, IBM, is trading at 244. Just say 244 exactly. Again, just keeping it simple. We know the strike. We know the risk-free rate. So with that information, we can calculate the value of a long put, can't we? The long call, it's going to cost us 795. The PV of the strike is the 270. Discounted at the risk-free rate, we're saying it's 4%. We're assuming it's exactly 12 months. So to the power 6 over 12. Short the stock, so minus, that would cost us. That's a cost we have to invest. We'd sell the stock, so we'd knock off the proceeds from sale today, 244. That would give us 28.71. So in theory, if we've got the right risk-free rate, and that applies for those 6 months, and there's exactly 6 months to expiry, if your call is priced at 795, your put should be 28.71 on the same stock with the same strike and the same expiry date. What happens if it's not? What if this put is actually at 30? Well, if it's at 30, this is not equal. And you follow the age-old rule of buying low and selling high. We know this side is going to cost us 28.71. If we sell the put, we are going to pocket 30. The difference is an arbitrage gain. Why? Because these two positions will pay off the same. If they pay off the same, you've got no risk. You just sit back and enjoy your arbitrage gotten gains. You would sell the put, so go short the put. The right-hand side, you go long the call, invest, and short the stock. Now that is a comprehensive coverage of put-call parity. I don't even know that they'd go that far to start making you play around like this in level 1. They could, but at the very least know why it works, what it's achieving, and the fact that it's driven by the equality of the payoffs telling us these two sides must cost the same.